One of the most important things when we are talking about putting computer vision models into production is model evaluation. So let's say that we're training a few different models. We want to see how it perform on our data set. We usually take a test set and then we can test our models based on that. This is a pretty time consuming task. There's a lot of statistics, a lot of evaluations and so on that need to get done, but it's very important when you're actually building models, making sure we get the models with the highest accuracy. You might test out different models, you might test out different variations, subsets of your data set and so on. This is what we're going to go through a full guide on in this video. So we're going to use fitfyone model evaluation. We're going to test out a few different models. You can use the YOLO models. All different models are supported directly out of the box. You can just load them in, your own custom models, run evaluations on your dataset, and then you can see visually the whole UI and the app. We can see the predictions, ground truth. You can see where your dataset performing bad, where is it performing good, and all these different evaluation metrics. So let's just jump straight into the Voxel fitfyone here website where we have this model evaluation. You can see some of the UI here. It will show you the model performance, prediction statistics, confusion metrics, different subset distributions, and all of these, and do comparisons side by side if you have multiple evaluations running. So this is pretty much just what we're going to run through. Let's just jump straight into our Google Colab notebook. All this information will be available under the video here in the description. And this is just covering everything into details. We have videos covering all the different technical details, all the theory and so on going on under the hood here behind the scenes. So we're going to go through a few examples. We're going to run some real world evaluations, see the results, how we can use fitfyone to do our model evaluations. Because when we're training computer vision models, deep learning models, doesn't really matter what we're working on with AI. The data is the key. So the data is the most important when we're working with these models. Like trash in is also trash out. So we have a Google Colab notebook here. Again, it will be down in the description as well. Let's just connect to the runtime. So we're going to see how we can add predictions to the data set, analyze the detections, evaluate the detections as well, run multiple evaluations, and test out some models. If you go inside the documentation of fitfyone, it will also be down in the description. We can see all they have available, how we can set it up. It's open source. They also have an enterprise solution if you want to do some of it a bit more from the UI, generate image embeddings so you can do comparisons and visually see what are the embeddings in your data set. So this is pretty cool. You can see the Google Colab notebook, the GitHub repository. We can just open that up as well to take a look at that. But all you have to do is just pip install fitfyone. So this is the GitHub repo, fitfyone. There we go. Open source, you can use it for free. If you need some of the enterprise license stuff, it's definitely worth it as well if you really want to have the best model performance and doing some large scale stuff. So we have the installation, pretty easy. I'm going to run it in just a second. We can load some data sets. You can load your own data set. They have different model support and so on as well. We can load it in. We have the model zoo, we have the data set zoo, so remote data sets, built-in data sets, and here we can see the built-in models. I'm going to show you a guide on how you can do it with the YOLO models. So most of you guys are probably just training a YOLO model. You can do your own fine-tuning on your own data set, load it in here with fitfyone, and do all the model evaluations. So AlexNet, CenterNet, all the different ResNet, YOLO, Clip, Coco, all these things here are supported, and you can just specify the tag here or the name of the models and it will load it in. Tutorials. Tons of tutorials covering here. The one that we're mainly going to focus on in how we can evaluate object detections. So bounding boxes around our objects and all these things, but the metrics is pretty similar. So this is a pretty cool one. Let's just jump into our Colab notebook and see some of the stuff. We won't go through everything. We'll go through the most important for just getting model evaluations up and running when you build computer vision system. So let's run this, pip install fitfyone. That's all we need to do. We can pip install Torch and Torch Vision as well. You can run this local, you get the UI, you will get the app and so on that you can play around with local as well. But the cool thing, it also works in a Colab notebook. So if you're doing model evaluations, different training runs, so on, you're most likely in a notebook already. We don't need to pip install Torch and Torch Vision here. Should already be pre-installed in our Google Colab notebook. So now we can just import fitfyone.zoo. Then we have our FO set. We load our zoo model. We're just going to load a ResNet 50 trained on a Coco dataset. So this is a faster RCNN, very good open source model for object detections too. So it will just take a second here to install. You don't need to do anything. It will install everything based on your environment, and you should be good to go. Let's just run the block here. It's just going to load the model. We can load multiple models. You can go in and take a look at which models are available. You can just open it here from the Colab notebook. It will redirect you to the model zoo, and then we can see all the different models available. So right now we have taken this ResNet, CenterNet. We can try to take another one. Let's maybe just grab this one here. Well, let's try to see if we can find a YOLO model. Let's find a YOLO model. Fast RCNN, Nash. So which one do we have? We have the Fast RCNN, ResNet 50. So we could, for example, take a ResNet 101. That's a pretty good comparison as well if you need the more layers and the bigger model in your architecture when you're actually using it. And the only difference we have to do is just copy paste this one and swap it out. So let me paste it there. We can take model 1 and then we'll use model 2 later on for some evaluations. And you can specify if it's Torch or TensorFlow. So the model that we're going to compare it with, let's just grab a YOLO model. You guys are probably very familiar with that and how to run it. Let's just go with the newest one from Altalytics. So we have the YOLO Nano. Let's just go with the smallest model. We have Coco, trained on the Coco and in PyTorch. So let's go back here. We just need to copy paste this. We have our model 1 and model 2. Let's call it model YOLO instead. And we can run predictions with these two models in just one line of code, and then it will load it into the dataset and we can see our differences. So everything should be installed now. Let's set up our models. We need to install Altalytics to be able to run the YOLO models. There we go, we can rerun it. And after that, we can load in a zoo dataset. So we're just going to use the Coco dataset, the validation split from that dataset. So this is what the models are trained on, but of course the training set and not the validation set. So now we're just going to compare raw, the ResNet, fast RCNN ResNet model with the YOLO 11 Nano model. This is a very good performance and comparison because these models are some of the most used ones, if not the two most used ones. Let's see, we have our dataset, we can run that after. Our model is now updated here with YOLO after we installed it. Everything is good. We load our dataset. It will just take a few seconds. We can print our dataset here. So it's basically just going to show some information about our dataset, what we can use. You can use all the different views you can see inside the documentation and everything as well for 51 here. So if you go to the API reference, everything is available here for the internal, the base, the dataset classes, everything that you can see in here. We're still downloading our dataset up here. So here we're downloading our annotations. Here we're downloading our images, and now we're just downloading our validation split. So you can usually divide it into our training, validation, and test split. The validation split is just for model evaluations, doing hyperparameter tuning, and all of that. We will never train on our validation set. It's doing comparisons, model evaluations, and making sure that our model generalizes and doesn't overfit to our training data. So now we have 5,000 images here. Then it will print some information about the dataset. There we go, 5,000 images. We have images, evaluation, detection, tutorial, and this is all the fields that we can extract from it. So it has an ID, file path, tags, and metadata. The cool thing about tags is that we can filter our data way better inside the app. We can assign metadata to it. Let's say that we have different environments. We have sunny, cloudy environments and all that. It can be attached to metadata, and then we can do subset comparisons and really just extract our data set. That is not possible with pretty much any other tool that I've seen out there. Here is a few lines of code that we need to run. It's very powerful with the other like training frameworks and all of those things. But once we get to the data curation, having your data in one platform, they also have annotations, labeling, and all that. But just for the model evaluation, it's one of the best data curation sites out there, and I'm using it for like production scale systems. So now we're just taking a sample of a ground truth detection. We have a potted plant. We have a bounding box. So this is the whole format that we're going to extract. You can just take the sample.id attributes if you have the assigned attributes, tags, and all of these things. So now we can launch the app. It also works here in a Google Colab notebook, but you can run it locally and all those things as well. So let's boot it up. After that, we can add our predictions to our dataset. 51, there we go. It's also very good to run local, might even be better, but a lot of times we're working in Google Colab notebooks when we're training our models and all of that. So this is pretty much our detections. We have our ground truth, or not detections, this is the ground truth labels from the Coco dataset that we have loaded in. You can load in your own dataset as well. Just go through documentation. They have guides and tutorials on all of it. If you just go in here in the tutorials tab, there's like evaluation, update detection, fine-tuning YOLO models. We're going to take a look at this in just a second, but basically you can just load a detection model, segmentation model. You can get the results. You can train it with analytics. So for example, here we load the YOLO model. You can just train it here, and then you can apply the model to our dataset, and you can see everything in there. So that's pretty much it. That's how you can just like grab a dataset and get it in there. But you can see all inside the documentation. Let's go back. We have our ground truth. We can have some sample tags. You can have label tags. I'll show you in a second when we try to extract a subset of a dataset. So this is pretty much just the app. You can go through it. You can click on an image. You can get the ground truth model predictions. It's going to make way more sense once we get some predictions in there. So all we have to do right now, we'll just take a random subset of our predictions or our dataset, so we can do predictions on that. So there we go. Now we can just predictions view. We create a new view. This is going to be for our session. We apply a model. We specify the model that we want to apply, and then we have our label field, so that's faster RCNN. Let's just do it in one go here with the two models, or I'll just do it in 2 blocks of code. Today we have the first one. The second one, we're going to apply our YOLO model, and here let's call it YOLO 11 Nano. It's going to run all the predictions on our subset of data. You could have taken the whole data set if you want to run that for the evaluation, but it will just take longer to get up and running. We're going to run the predictions on our YOLO model. It will take a bit of time. Right now I'm only connected to a CPU, but it does support GPU as well, and then we can see it inside our app. So it'll just take a few minutes here on CPU to run all the detections through our images for both models, and we can see it inside our app. So after we have our model predictions, we can just go down and set our predictions view equal to our session view, and now we can see we have our detections in here. So then you can go in and do your comparisons between the ground truth and what the model is predicting, and you can compare multiple models in here. So let's just take some examples here and see if we actually get good detections. Let's just go with the first one here. So we got a person detection. The blue one is the YOLO Nano model. We detect this as a snowboard because we pretty much just missed this bottom part here. I don't think this is the same ski, so this might even be a mistake in the Coco annotation dataset as well. So we're getting pretty good person detection. Might even be better than our label as well. So this is just one example. This is how you can go through and see them. You can compare models, how good are the bounding boxes fitting around the objects, and so on. We have another example here. Let's try to take a look at that. We have a vase. Looks pretty good. Here we have, I think it's a potted plant. We don't have that in our annotation dataset. We have a vase here, and we also have a table. So here we can see the ground truth. Here we can see the predictions we get with the YOLO models. So this is very good. You can add all these metadata, tags, and so on. What you can also do is to go down, analyze the detections, so you can visualize the bounding boxes, view different tags, all these things here, select region of interest, confidence thresholding. So if you want to have the detections above some threshold, you can also go in and do that. Usually I'll just do it from the UI. You can do everything programmatically as well, but you can also just do it inside the UI. So if you want to filter based on the confidence, for example, I usually just do it through the app, and we can go in and set the confidence, and then the detections would pretty much just disappear. If you want to see which predictions are having high confidence, which are having low, we can have the mask path. You can do intersection over union and all those things as well. For the ground truth, you can filter by labels, mask path, IDs, and so on. The most important here is probably just the confidence. So everything can be done through code or just the web app here. I usually just take my predictions, do model evaluations on a few different models that I've trained. Usually you will do it on the same model as well. You can have different dataset variations as well compared in here too. It could also be high parameter tuning that you're doing, but that's everything. These are pretty much just like step-by-step and documentation for like how to do confidence thresholding, confidence in Python, viewing object patches, evaluating detection. So here you can, for example, like run evaluation. So we get all the intersectional unions, mean error positions, and all those, so we can see it inside our UI. So just try to run this one here. So we don't have our high confidence view. We need to make sure that we do that. To have a high confidence view here, we need to define it. Do it with our yellow model, yellow 11n. Filter by based on confidence score. You only want to have the highest confidence score predictions here. We can print it as well. Let's now just go down. You can set the session view and it will open that view up with only those annotations and reload it. Now we can do our evaluation here. If we change this, yellow 11n. We compute our mean error position, we'll get our evaluations, and then we can open it up inside our UI as well. We can aggregate the result, sample level analysis, all these things here. You can go through them in just a second. I'll show you how we can do it on a subset and just the model evaluation tab in there. So everything is possible. I pretty much just try to keep it as simple as possible, do some model comparisons, have a nice overview we just load in a few lines of code, and that's pretty much it. We just need to know what is wrong with our data, how can we optimize it, because everything is in data itself, retrain the models, and then we have the best models that we can iterate on. So now just go up here and reload this view. I'll just set it down here for evaluations. We can aggregate the results, we can have top 10 classes, you can print the mean error positions and all these things here. So let's just rerun the app. We set our session view to a predictions view. We show our session, it will take a second here to boot up, and then we can see our new results from our code. So while it's just loading up here, we can go in and grab one of the other examples. So if we go inside our user guide, we have this evaluating model. This is pretty much just what we're running. We run our evaluate detections. This is the one that we just ran on our predictions. We can do per class metrics and all these things here. But one of the cool things, which is also new, is just analyzing scenarios. So it could be that you want to analyze edge cases. You have a data set where you have like sunny examples, cloudy examples, raining examples. You want to split your data set based on that, and then you might only want to evaluate your model performance on sunny images. Could be like self-driving car or something you're creating, just detecting things out in the environment. And then your models, they might be struggling if sunlight is coming into the camera lens or something, and then we can filter specifically for that. You can clean up your data set, see if there's any bad examples that you can remove, how you can optimize it, and then you can do a model retraining, and your model will most likely perform better. So usually I just go in here, take the user guides, documentation, go in, copy paste it. When I'm running full model evaluations, it's just a few lines of code. Spin up my own notebook with my training scripts. We can just run this one after, but here we pretty much just have our evaluation. So what we can do is go up here, and we have embedding, so you can create image embeddings, you can create histograms, and we have model evaluation here, and now we will get a new eval. You can go in and create an additional evaluation, so you can do comparisons side by side. But if you just take a look at this one here, and then you will have all the histograms, all the charts and everything side by side. So you can have this scenario analysis, everything can be done through the UI as well. So this is a new thing that I'm going to show you in just a second. So we have the mean error positions. It's pretty low on this one here. We have the precision, recall. Our precision is very high because again, we set this is the confidence score above 0.75. And we just get rid of everything else. So we have a lot of recall, we miss a lot of detections obviously, but this is how we can do our evaluations. You can see our metrics performance, precision intersectional union threshold, precision recall, F1 scores, class performance, and one of the ones that I use the most is the confusion matrix, where we just want to see all the values in our diagonal. So now we know how we can run our evaluation. I'm just going to copy paste this code in. We will grab a subset of our data set with some sunny, cloudy, rainy examples. We're going to run our evaluation. We just have our ground truth filled and our evaluation. You can call it whatever. You can call it eval 1, 2, 3, and all these evaluation keys will go into the UI so you can do it side by side comparison. So now we have our evaluation done for our subset, and the only thing that we have to do is pretty much just run our evaluation. Let's go inside our documentation again. We have this one here. We can print a report of our full results, but we can also see it inside our UI. So just start with printing the results here of a report. There we go. We can see our precision, recall, F1 score, and our support for the classes. So we have person, kite, car, bird, and carrot. A pretty good precision for our bird, person, and kite. So we can definitely see here that we're struggling a bit with cars when we have sunny examples. Could be cars driving around. We get the sunlight into the camera. So let's take a look at how we can actually just grab the results. We can print the report with our subset, and that's pretty much everything that we have to do. So let's grab this one. You can take sunny examples, you can take small objects, you can filter based on the bounding box area. If you want to have all these things here, we just have to set up our dictionary with our attributes, and we have this use subset. Could be a save view, compound subset as well. You can use that if you want to use multiple examples like small objects and also sunny examples. So just try this one here. It will print the report as well, and you can also get the subset view. So let's go in here, go back. It's going to do the exact same thing, but we can also do all these things here from the UI. So it's going to launch our app again. We have our session. Let's just run it. Let me see where it is. This one. Let's run it down here where we have all the other stuff. So now we have our ground truth, we have our predictions. What we can do is now go inside our model evaluation. There we go. We grab our evaluation. Now we go inside our scenario analysis. We can go and create a scenario based on the data set that we have. So you can attach different like metadata, tags, and all that we can filter it based on. You can also add custom code and so on. So let's just call this sunny examples, just sunny. Sample field, we can grab that. So the field here, you can take tags, metadata, all different stuff. Let's go for the tags. We have cloudy, rainy, sunny, and validation. So this is the full set. Let's take our sunny subset that we have created. So this is a new feature that they have, and we're only going to analyze this scenario here. So we're running into problems with our models not being able to detect cars driving around in sunlight. So let's see how we can improve that. We're getting some wrong detections. We can see that we get all different stuff here with our model performance. So very low precision. We have okay recall, intersection over union, F1 score. Again, this is just a subset of data. We get our confidence distribution, our metric performance. We have our subset distribution as well. So if you're training multiple different models and want to evaluate them side by side, you can also do it here, and it will show up pretty much just side by side. You can create multiple scenarios. You can go through them step by step, and that's pretty much it. You will get a high level overview over how are these different subsets performing on your model. So this is one of the new features together with this model evaluation tab, where you can just see everything in here, go step by step. This is all we need. This is like a full walkthrough. You can go through the notebook. There's tons more details also in the documentation, but at the end of the day, you just need to know what is model evaluation, why is it important, and then I'll try to keep it as simple as possible. So we take our models. Usually I use the same model to train on, but could be cases where you have multiple different models you want to compare to each other. I usually just have different model configurations, and all these things could also be different data sets that you want to compare. Everything is possible in here. So thanks a lot for watching this video here. Make sure to go in, check it out. Everything will be down in the description. You can run a Google Colab. One of the coolest things with this framework is definitely you can run it directly in a Colab notebook. It'll run local as well, but it's just so much better to have it right where you're training your models. Stay tuned for upcoming videos. We're going to launch one where we're going to use a YOLO training model, where we actually just use the few lines of code where we have the model, we train it, we evaluate it, and that's all we need. Then we can take our models, export it into an optimized framework, put it into production, and that's the whole computer vision pipeline.